Hello guys, welcome back to Maison African Motives. Still on our Mechanotechnics revisions, working on the epicyclic gear train. We are going to consider November 2022 exam that we have on question number 1, whereby we are given in an epicyclic gear shown in Fig 1, the driving gear A. So we are given the driving gear A. Let us just do this so that we can properly see our diagram. So A is our driving gear in this case. So meaning to say we are referring to the sun gear in this case. A has got 18 teeth in this case. So TA, it's 18 representing our sun gear, and the fixed annular gear, the fixed, which is EC, is our annular gear in this case. All right. So TC has got 120 teeth in this case. This is our annulus in this case. It's and it's fixed. All right. So we have got the fixed annulus, and also we have got the number of teeth on gears E and DR. So we've got this part of E, the number of teeth for E corresponding to what we have in this case is 100, and that for D is 40 in this case, which is our D in this case. So TD is going to be 40. All right, so from the information that we are given, we have like the information for the sun, for the annulus, and from this part is we have our annulus in this case, which is the ring gear. B is the planet gear in this case. So we've got the planetary gear in this case, which is B, and the sun, which is A, and F here is being our arm. All right, then we've got gear D and gear E on the other part. So the question here is we are given if 4 kilowatt is supplied to gear A at a speed of 1,500 revs per minute. So we are given the power at gear A, and also we are given the speed of gear A in this case. All right, so we are given the power of the sun, which is the sun in this case. So we are given that at A, the power is given as 4 kilowatts at that condition. And we also have the speed of A, which is 1,500 revs per minute. That is for the sun gear in this case. All right. So the question is, calculate the following. All right, the first part of our question is to calculate the number of teeth of gear B, the number of teeth of gear B. Which part is representing our gear B? If we are to check on our diagram, gear B is our planet gear in this case. So we are supposed to calculate the number of teeth on the planet gear. Remember, on the planet gear, since we have the number of teeth on the sun, and we also have the one on the annulus, we can calculate the number of teeth of the planet gear from the formula. Remember, from the formula of the number of teeth on the annulus is equal to the number of teeth on the sun plus 2 times the number of teeth on the planet gear. So in this case, the annulus being the annulus in this case, we are told the fixed annular, which is C. So we are going to have this as TC is equal to the sun gear. The sun in this case is A, TA. This is N, the sun. So in this case, this is TA. So you're going to have TA plus the planet, which is B, the one that we are supposed to calculate, which is going to be 2TB. So remember, we are asked to calculate the number of teeth on B. So meaning to say, we can have this formula as we can see. We can substitute what we are given by making TB the subject. We can subtract TC, TA to the side is going to be a minus. Then we divide by this 2. That means we're going to remain with TB in this case. So TB is going to be TC. We have this part, the number of teeth on C, which is the annulus, that is 120 minus TA, the sun, which is 18, everything over 2. So this is going to give us the number of teeth on the gear B, which is the planet gear in this case. All right, so this is going to give us 51 at the end. So we are going to obtain 51 teeth if we divide properly in this case. All right, so that is the number of teeth that we're going to have on B. Then on the other part, they're now asking us 1.2 to calculate the speed and direction of rotation of gear E. 8 marks for that to calculate the speed. So what we are going to consider now from, we are going to actually apply our table of motion in this case. So as you can see, we are going to consider the sun, we are going to consider the annulus, the planetary, the arm, gear D, and also gear E. But as you can see from our diagram, gear B, which is our planet gear in this case, is linked directly to the gear D. So meaning to say these two, they are at the same speed. So that is another part that you must consider. These two are at the same speed. All right, and we shall see that part later on. So let us see. As we can see, we have a lot of gears in this case. So we're going to consider a lot of gears, 5 gears in this case. So I'm just going to draw the table so that we do not waste much time. So let me just draw the table. All right, so this is what you have at this part. So as for me, I consider much is better that we just have our condition. Then we start with the annulus, the planetary, and the sun gear. Since we are used to the formation of what happens between these three. So in this case, remember our annulus in this case was the annulus in this case, that is C. In this case, we're going to consider the annulus, which is gear C, the planet, which is gear B. So that is just, sorry for that confusion part, all right? So this is gear C, which is my annulus in this case. Then the planet gear, remember that was gear B. The sun, that is gear A in this case. Our sun here is gear A. All right, then the others, I can just write them in any order that are remaining. We are remaining with the gear D and E in this case. Gear D, the one that we say is linked to B, so we've got D and E. So we're gonna have gear D and also gear E in this case. And also we have got the arm in this case, the arm, which is F. So our arm there is at F. All right. So that is it. Then also, let us just consider what we have about C. Before C, we calculated, or we are given for C, the number of teeth there is 120. For C, we are given 120. The number of teeth here is 120. And also remember about C, they told us that C here, it's a fixed annulus, all right? C, it's a fixed annulus. So meaning to say, it's always fixed, this one. So its speed, it's also fixed. So the speed of C is gonna be at 0 revs per minute. All right, then let's go to the planet gear, which is gear B. Gear B, our planet, we do not have anything. Okay, we calculated its number of teeth. We got 51. Here TB, we got 51. So we've got the number of teeth of B, which is 51. The sun, which is gear A, which is our sun gear, it's 18. The number of teeth there, it's 18. That is TA, it's 18. And also we have the speed of A. We are given the speed of A. That is, it's at 1,500 revs per minute. Then gear D, D, we've got the number of teeth, which is 40. All right, so there we just have the number of 40, D, which is 40. Gear E, we also have the number of teeth of gear E, which is 100. All right. So that is TE, it's 100 in this case, and the arm is the one that we need the speed. Okay, we need the speed of rotation of gear E in this case. All right, so let us consider what we are having here. So remember our condition always it's fixed for the first step that we are supposed to fix the arm in this case. All right, so what we are going to do is to fix the arm, and our arm is F in this case. We are going to fix the arm F. And what are we going to do in this case? We are going to rotate to rotate the annulus. In this case, you rotate the annulus, of which the annulus is gear C. So we are going to rotate the annulus in this case, that is gear C, which is our ring gear. So 1 revolution. So we rotate this annulus, the bigger wheel, 1 revolution clockwise. So that is plus 1 revolution. So it means on gear C, that is where we are having a rotation of 1 revolution clockwise. So there's nothing that we're going to consider there. Then let's check what's going to happen on the planet. Remember, the planet is going to drive the annulus in this case. The planet, this is where we have our planet gear. And these will be in the same direction. The annulus and the planet, we know that these go in the same direction, which is clockwise. Clockwise is going to be the driven, which is the annulus, that is going to be TC, the driven over the driver over TB. In the both there in the clockwise. So that's 120 for TC. We have got 120 over TB. With this case, that's 51. So that's going to be 2,5. 2,3 actually 2,353. All right, so you're going to obtain 2,353. Then for A, which is the sun gear, remember the sun is affected from the planetary outer part of the annulus. So meaning to say our A, which is the sun, is going to be affected from the move that occurred before as the annulus. So we're going to consider the annulus over the planetary. Now the sun is driving, the sun is driving the planetary in this case. So the sun is going to be, since the planet is going clockwise, the sun is going to be considered in the anti-clockwise. So meaning to say, remember, it's affected first from the annulus that we had before from our TC. So we had the TC over TB before. So we're gonna multiply now the sun driving the planet. The planet is gonna be clockwise, which is a TB, but the sun in the anti-clockwise is gonna be minus the sun, it's A, which is gonna be minus TA. So this is what you're going to have at the end. As you can see, the TB and the TB will cancel there at the end. So, but we are having TC over TB multiplied to TB over minus TA. So as we can see, this part and this part will cancel. We remain with the TC over minus TA. All right, so that's it. TC, which is 120, so it's gonna be 120 over minus TA. Remember, TA it's 18, so it's gonna be minus 18. All right, so let us see what you're going to have. 180 over minus 18 is going to give us negative 6,667. All right, then gear D, remember gear D and B are linked to the same point I explained from the diagram here. This is where we have B and D, so they're at the same point, so of axis, so we are going to have the same speed in this case. So meaning to say we are going to obtain for D as 2,353, just like the previous part. All right, let us consider now E. What is going to happen on E? All right, the E, if we are to check on our diagram here, this is where we have E. All right, this is where we have our E in this case. Remember, we said there's a linkage that is happening. So here E is going to be affected by D. All right, since here we are saying this is going clockwise. So what is going to happen now is that we are going to consider D going in the clockwise because of the linkage. It's on the same speed with the planet. Remember, it's on the same speed with the planet here. So as D is going to be rotating in the clockwise, it is going to maintain the same thing. E is going to maintain the same property as the annulus also. So this is going to be considered in the clockwise. So the driven part now that we are considering is going to be what? TD in this case. All right, so we are going to consider after this linkage that we are given. So we are going to consider now E affected by what? By D. All right, E being affected by D. So meaning to say our formula at the end, we're going to take it from TC. All right, so this we're going to take it from TC of TB that we had before. So it's going to be over TB times, we're going to have TD over TE in this case, all right? So it's going to be TD over TE. So in actual sense, it was supposed here, it was supposed to be TB here. It was supposed to be TB. But what we are seeing now is that because of the linkage that we are having of what? Of D and E, of D and E in this case, the link that we're going to have of D and E. So it's going to be TD over T over TE. So this is going to be in the positive because of the direction that D is going, all in the positive. But here we calculated TC over TB. If we want, we can substitute as it is here, TC over TB, which is going to be 120, TC over TB, that was 120 over 51 times TD over TE. So TD, that is going to be 40 over TE, which is 100. All right. So what are you going to have at the end is going to be 0.941. All right. Then what about the arm? Remember, the arm is fixed. Fix the arm F. So the arm here it's at a fixed point. So it's going to be a 0 in this case. That is nothing about the arm. So that is the whole part of the first condition. Then the second condition, as we know, we are supposed to multiply by what? We are supposed to multiply by X. So we're going to multiply by X and we add Y in this case and add Y. So this number, you multiply it by X, 1 times going to X plus Y. This number, you multiply it by X, then you add Y. This number, you multiply it by X, then whatever that you get, you add Y. This number, you multiply by X. Whatever that you get here, you add Y. This number again, you multiply by X. So that's the whole idea. You multiply by X, you add Y. 0 times X, that's 0. You add Y. So that's going to be Y in this case. All right. Then the last stage, you consider the given condition, the speeds that we are given. Are we given anything now to say, this one is fixed? The only thing that we know is the fixed, the annulus they told us about. That the annulus it's fixed. So we are going to take the speeds as they are. There's no other condition that we are given later on. So that is the only part that we have. We only have these speeds that we have, knowing that the annulus is fixed. So that's why we are having the speed of C being 0. So the speed at C, which is our annulus, is going to be at 0 revs per minute. In this case, we are given that this one is fixed. So it's going to be 0 revs per minute. Whereas we have the speed on A, we are given the speed that is affecting A in this case, which is the sun gear, which is 1,500. In this case, we are given the speed of 1,500. So that is 1,500 revs per minute. And that is the only part that we have. And the question is asking us to calculate the speed and direction that is affecting gear E in this case. So we need the speed of gear E. So what is going to be the speed of gear E? We do not know the speed of gear E. That is what we have. What made this to be a 0? It's a fixed annual that what we have. So we're gonna put here for C, that's a 0. For the planetary, which is B, there's nothing that we have here. For A, that is 1,500 positive. For gear D, there's nothing here. For gear E, that is the one that we are supposed to calculate its speed. For the arm, there's nothing that we're going to consider here. So this information that we have is enough. Remember, from your table, what you are going to do is to equate the XY that we have, we equate now to their corresponding values. So meaning to say here, X plus Y is supposed to give us a 0. We have formed an equation. Here, there's nothing that we're going to equate. Here we are going to equate to 1,500. So negative 6,667x plus y should be equal to 1,500. Then here also we're going to have 0.941x plus y in this case, which is supposed to be equal to the speed of E, which is the one that we need. So as we can see, the speed of E is consisting on this formula, it consists of X and it also consists of y. So this time there's no way we are supposed to solve for both the values x and y. Without x and y, we cannot calculate this speed. So we need x and y. So we can just make our substitution as usual. So in this case, from equation 1, let us just say this is our equation 1. This is our equation 2. So from equation 1, I'm just going to make y the subject in this case. Y to be the subject, y is equal to x to this side is going to be minus x. So if y is the subject, or you can even make x the subject if you want, x is equal to minus y, still one and the same thing. So you substitute what you want from the substitution, all right? So in this case, I'm just going to make y the subject, x the subject, that is y is equal to minus x. So substitute this now in equation 2. In place of y, you're going to substitute minus x. So meaning to say we are going to have minus 6,667x. Then in place of y, that's plus minus x. So it's going to be minus x, which is equal to 1,500. All right, so you can simplify, that's -1 here. So collect like terms already here. We are going to obtain -7,667x, which is equal to 1,500. So divide by -7, this side, we are going to obtain -195,644. All right, so that is the value of x that we are going to obtain. But remember, from the equation 1 that we made y to be the subject, we said y is equal to minus x. So if y is equal to minus x, it means y is equal to minus the value of x that we got here, which is 195,644. So that means a negative is going to be a positive. So that's 195,644. So that is it. We have the value of y and we also have the value of x. Since these two are needed to calculate the speed, as you can see that the speed of E, it consists of x and it consists of y. So we are going to have this as 0.941 times x. Our x in this case, which is this value, which is a negative 195,644 plus the speed of y, the value of y in this case, which is 195,644, which is a positive. So at the end, this is going to give us the numerical value of the speed that is going to affect E in this case, which is 11,54299 like that, which is going to be 11,543, round off to 3 decimal place, and that's a positive in revs per minute. So as we can see, it's a positive, so it means it is in the clockwise in this case. That is clockwise. If it is a positive, a negative, that means it's an anti-clockwise. So that was the whole situation of the question. That was the whole part of the question. All you just needed was understanding on your table how these gears are being linked, are being connected, and the effect of one gear to another, and also the information. Sometimes you see this part of the annular being fixed is something that you are already given, or from the first information here, you are already told that we have got the fixed annular gear C. It's a fixed part, it's or fixed. So its speed, if it is fixed, is going to be always at 0 because there's no movement there. It's a fixed, so the speed is going to be at 0. So that's it. And understanding your diagram, the properties of the diagram, what is making up that diagram? It's made up of what? That is the whole important part. And your formulas, as we know, definitely our formulas, to know your formulas and so forth. So that's what we had. Shall keep on having more questions as we move on.